Welcome back, folks. Today we're going to start off another little project with our partners over at PCBWay, and we're going to design a fan controller. Before we get into this, I just want to mention that PCBWay have extended their 10th anniversary all the way through the month of August as well. So let's go over there and take a look at that. Start PCBWay's 10th anniversary tour. And now you do have to be a registered user to this, so they'll ask you to log in or create a user ID at this point. Now if you go in, it'll give you your story. If you're a brand new user, of course, you're not going to have much of a story. Now it tells me here that I first utilized their services in March 10th of 2018. I thought it was a little bit earlier than that. Now in this section here, they give you a bunch of coupons. This one here is especially nice, but then there's a lot of good ones here too. And this one here, it's a history of PCBWay itself. So it's just a short little video that you can watch and see what basically their history is. And the next section here is this globe. So you can you can participate here by choosing where you live, and I'm in Canada. So you can drop a pin here and put a little picture and a little one-line story if you want. And now I should mention that if you're a first-time customer at PCBWay, you get your boards for free. Of course, you have to pay for shipping, but as long as the boards are in the $5 range, you get basically you get a $5 coupon to pay for them. If you haven't already tried them, you can give them a try for free. Just pay for shipping. All right, let's get back to this little controller here. So I built a lot of things that need cooling. Amplifiers, power supplies, loads. I modify badly designed ones and put some sort of cooling on them. And it gets a little bit annoying in the lab when you have like 5 or 6 machines with fans running in them all the time. So what I wanted to do was build a little standalone fan controller that I can pop into these projects or upgrade a project that's already existing with that. And this is what I've come up with here. So let's have a look at it. Now what I'm going to use in this case is a microcontroller. It's just a little pickaxe 8-pin microcontroller. It's called the 08M2. And it has an analog input and it has a pulse width modulation output. So I'm going to take advantage of those. What I'm doing here is I'm putting in a thermistor and just making a voltage divider between the thermistor and a standard resistor here. And then we're going to be able to sense the voltage there anytime we want to see how much the thermistor has changed. My idea on this one is I'm going to set it up so that the fan starts coming on at about 40 degrees C and increments its speed as it goes along through 50, 60, 70. So it's going at 100% speed when it gets up to about 70, 75 degrees C. And then it'll be full blast. So that's all done in software. But choosing this resistor down here, there's a little bit of math to that. Now, I'm not going to go into that here. What I will do is I'll leave a link to a document that I created about a decade ago on exactly how to do that and how to code for a thermistor in both Pickaxe Basic and in C for the Arduino. In that, I also go into the explanation of how to determine what the value of this resistor is depending on your circumstances. So look to that document for that. Other than that, I'm just going to sample that, and then we'll make up a pulse width modulation output here. That the pulse width modulation will get greater and greater and greater as the temperature goes up. It goes into this nice little 2N222. That'll handle up to an amp. I've got it set up here to be able to fully turn this on up to a half amp. And that should handle a fairly decent sized fan or 2 small fans or even a tiny fan, whatever you like. And then here's the power supply for this. This one's up here for 12 volts. Yeah, you could also probably run this at 24 volts. If you wanted it at 5 volts, you could do away with most of the components of this power supply here. I would, however, because you're switching on and off a potentially inductive load here, I would put in this little filtering before you go from your 5 volts. So you take your 5 volts and go through the filter and then come into your microcontroller here. So the filter here is just made up of a couple of capacitors and a ferrite bead. And then it goes into a 100 UF capacitor just before we go into the little regulator here. And we've got the usual capacitors around the regulator as required. And that feeds the 5 volts into the microcontroller. And that's it. So this is a very, very simple little circuit, not much to it. And this is what we have for a layout for it. So I wanted to keep it a reasonable size, so I've packed in fairly densely for a through-hole board. I could have made it much smaller if I used surface mount parts, but not everybody is comfortable with surface mount parts. But this is it. So I've got all the traces are on one side, and of course the back side is just one big ground plane. And I'm going to send these off to PCBWay now. We should have them back in a week or two, and we'll build one of these up. And I got to find something around, maybe that power supply that I built a few videos back, because that's the fan in that is fairly noisy. So maybe we'll pop one in there, quiet that down. Between now and then, I'm going to create the code. And in the next video, I'll attach the code in the comments section. I don't imagine it's going to be very complicated, probably very trivial. Well, that's all I had for you today, folks. Just a short video to introduce this project, and we'll see you in the next video. Bye-bye, and thanks a lot for coming out.